Good morning, dear friends. Myself SS Sonigra. Today we are going to discuss about the solution of GTU examination question paper June 2013 exam in the subject of mechanical drafting. Last time we solved the first question of the same question paper. Today we will continue with the second question of the same question paper. The question number 2 is like this. A hexagonal pyramid, base 30 mm side and axis 65 mm long is resting on HP with two edges parallel to VP. It is cut by a section plane perpendicular to vertical plane, inclined at 45 degree to HP and intersecting the axis at a point 25 mm above the base. Draw elevation, sectional plane and true shape of the section. Last time we solved this problem. The solution of the same problem is like this. This is the hexagonal prism, isometric view, having hexagonal base and an apex point. This point is called an apex point of this pyramid. This is the base of the pyramid, and its top view and front view would appear like this. This is the top view of this pyramid. If you look from the top side, it would appear as an hexagon like this. These are the slant edges, and in front view it would appear like this. This would be its front view, a triangular shape. Here it is given that so till now we have drawn these first two lines. Now it is given that it is cut by a section plane perpendicular to vertical plane and inclined at 45 degree to HP. Now we have to cut this solid in such a way that a cutting plane makes an angle of 45 degree with XY line, and it passes through a point which is at a distance of 25 mm from this base. This is the base. So from this base on its axis, mark a point over here which is at a distance of 25 mm from this base, somewhere here, and from this point draw a line which makes an angle of 45 degree with XY line. So it would appear like this. This is the cutting plane line. Now if you cut this pyramid at this angle like this, what would appear? It in front view, in top view, and what would be its true shape that we had drawn last time. And this is the solution of the same problem. This is the front view, this is the cutting plane. It cuts this pyramid at a distance of 25 mm from this base. This is 25 mm from the base, and this point, from this point a cutting plane passes which makes an angle of 45 degree with XY line. So this line is drawn at an angle of 45 degree. This is the sectional top view of the solid, and this is the true shape of the section that we drawn in the previous lecture. Now next question. Question number 2A, asked in option for 7 marks. Data is given like this. A transparent cylinder container, diameter of base 60 mm and height 75 mm is full of water. It is tilted by 60 degree from vertical so that some water from it is drained out. So here a transparent cylinder is given, a cylindrical container is given, diameter and height are given to us. It is filled up with water. It's fully filled up with water. It's a transparent. So its front view and top view would be rectangle and a circle respectively. Its top view would be circle, its front view would be rectangle. Now it is tilted. It is given that it is tilted by 60 degree from vertical so that some water from it is drained out. If you tilt a cylinder, some of water would be drained out. Draw the surface of water in plan and elevation. Here it is given like this. This is a cylinder which is filled up of water, isometric view of the cylinder, and if we draw its front view and top view, this would be its front view, that is rectangle. This is its top view, that is circle. Height of this rectangle is given as 75 mm and diameter of this circle is known to us, that is 60 mm. Now in the second line it is given that we have to tilt this front view such that some of water would drain out and its axis makes an angle of 60 degree with XY line like this. it is tilted like this. If we tilt this cylinder at an angle of 60 degree, this would be its front view, and its top view would be like this. This would be its top view. If we look from top, it would appear like this. This upper circular face would appear as elliptical shape like this. This is the bottom shape, bottom face. Here dotted line would be there, which is not shown in this solid. Now here it is full of water, and here some of water would be drained out. So what should be the level of water in this condition? So here the level of water would be like this. This would be the level of water, because this is the seal point. From this point the water will drain out, so this much amount of water would be drained out, and here this water is filled up inside this solid or inside this cylinder. Now what should be the shape of this water level or this water layer? Of course it would be from here to this point. So to project this point in the top view, let me draw vertical line from this point like this, and its top view would appear, and from the vertical line from this point this would be its top view. This is the level of water or layer of water which is filled up inside this container, and as the container or is transparent, these all lines would be visible, and this upper face, this circular face, would also appear like this, that is elliptical in nature, elliptical shape. So it's like this. So here all these lines would be full line, because every edges are visible to us. So in this case it may appear that two solid lines may cross each other. Now how to draw this shape, this front view and this top view? Let me draw practically in our drawing sheet. Here this is the given data. Height of the cylinder is known to us, this height is known to us, diameter is known to us. Now we have to tilt this rectangle in such a way that it makes an angle of 60 degree with XY line. So that would appear like this. Draw a line at an angle of 60 degree from here, and from here. So just we have redrawn the front view, which is rectangle like this. It makes an angle of 60 degree with XY line. This angle is 60 degree. Now to draw its top view, let me take projections from each points. Let me consider this upper circular face, this face. So from here draw a vertical line like this, and from here draw a horizontal line like this. So both will cut at this point. So this is one point of intersection. Now here level of water would be horizontal line. So draw that level of water, and the level of water in front view would appear like this. This line shows the level of water. Now to draw the other points of intersection and its top view of this cylinder, let me take projections from top view, from front view like this. Vertical line from here, horizontal line from here. Here is one point. Similarly vertical line from this point, horizontal line from this point. So here is the point. By dividing this top view into equal number of parts, we can draw imaginary generators over the outside curvature shape or outside curvature face of the cylindrical portion. So divide this circle into 8 equal parts. Take projections in front view like this. So this is the projection lines to be drawn from top view like this. We can name the points. So this is point number 1, 2, 3, 4, 5, 6, 7 and 8, and respectively 1 days, 2 days, 3 days, 4 days, 5 days, 6 days, 7 days and 8 days. You can give any name. Now transfer all these points in this front view as well by measuring the distance or by drawing arc like this. So this would be the axis of the solid, axis of the cylinder, and here is one point. Now you can measure this distance with the help of compass like this. This is the distance, you can see here, and transfer this distance over here to have point number 2 and 8. Similarly, to have point number 4 and 6, you can transfer the same distance over here like this. And from all these points, draw lines to show the imaginary generators over the outside surface of the cylinder like this. Now from these points, draw vertical lines like this, from here as well as from here, as well as from this middle point. Draw vertical lines and horizontal lines from respective points. So this is point number 7, from point number 6 and 8, horizontal lines like this. So here we do have these points. Similarly, for the bottom face, bottom circular face, points of intersection would be here. One point is here, another is here. Similarly, from point 3, here is the point, somewhere here. So join all these points with a smooth curve. So that will give us the bottom face of this container like this. It would be elliptical, and this one would be dotted because it will not be visible, or it will be below, towards the below side, bottom side like this. So join them with the dotted line. So this bottom face is drawn by us. Now regarding this upper face, so in upper face also take these points, this is 1, 2, 3, 4, 5, 6, 7, 8 and so on. Draw vertical lines from each points like this, 1, 2, 3, 4, 5, 6, 7 and 8 like this. And similarly horizontal lines from respective points, and the points of intersection would be like this, 1, 2, 3, 4, 5, 6, 7 and 8. And join all these points with a straight line, and that face would be fully visible, so join them with a full line like this. No dotted line would be there, and all these points should be joined with the smooth curve. And by doing long practice, you would be able to draw a completely smooth curve in your drawing sheet like this. Now these edges would appear as solid lines like this and this. So we have drawn the outside edges like this. This is the outside edge. Now we have drawn the top view of this cylinder. Think about the layer of water which is there over here. So for that, let me pick up the points of intersection between this water layer and this generator. This generator is say point number 5 days. Here is point number 4 days, 6 days, 3 days and 7 days, 2 days, 8 days, and this is 1 day. So on point number 5 days, here one point is there. So from this point, that is intersection of 5 days generator and water level, from that draw straight vertical line like this. This is a projection line like this. And from point number 5, it is here. From point number 5, draw horizontal line. Both will cut at one point, and this is that point. That is point number 1. First point of intersection to show this curve or shape of water layer. Now second point is here. First point we have picked up over here. Second point is here, which is on 4 days and 6 days. These two generator. So from this point again draw straight vertical line. That would be like this. Straight vertical line. From 4 and 6 horizontal line. From 6 horizontal line. From 4 is the horizontal line. Here is the point. One is here. Another is here. So again we have picked up 2 points. Similarly, here is the point, intersection of this water level and 3 and 7. So from here draw straight vertical line up to horizontal lines from 3 and 7. From 3 it is here, from 7 it is here. So from 3 and 7, 2 points are here, one is here, another is here. So we have picked up another 2 points starting from here, 1, 2, 3, 4, 5. So on this side we have picked up all the points. Similarly on this side also find out the points of intersection. Here is the point, from here draw straight vertical line, and this generator is 2 days and 8 days. So from 8 and 2 draw horizontal lines like this, from 8 and 2 somewhere here. So here is the points of intersection, and finally this is point number 1, that is over here. Now join all these points with a smooth curve. It would appear like this, and that is the level of water or shape of water level contained in this transparent cylindrical container. If it is tilted at an angle of 60 degree with VP, this shape would appear. This is the level of water, shape of the water. Of course, to show this shape of water, we can draw section lines in this section. It's optional because it is not a cutting portion, it is not a cutting plane, so it's not compulsory to draw the section lines inside this portion. So this is the level of water. You can write here, this is level of water, top view of the water, and this is the front view, this is the top view. You can write the answer. This is question number 2A, optional. In examination you write like this, 2A, or means it is asked in option, and with big letter write only 2A. People forget to write this one, which is very important. So I hope it's clear to you. Now next problem. Question number 2B, asked for 7 marks. Draw the development of a given pyramid in figure number 1. Figure number 1 is given like this, a square pyramid. Dimensions are given to us, height is 60, square of 40, and we have to draw its development. So how to draw the development of square pyramid? That we are going to discuss over here. Here a square pyramid is given like this. This data is given to us.